So hopefully after completing the last activity, you have an understanding that if we look at a graph of f at x equal to sine x, and I've just sketched a basic sine graph, and that's the same as y equal to sine x, that when you graphed their derivative, or all the slopes of the tangent, you ended up with a graph that looked like that. That should have looked familiar to you because that is cos x. So the derivative of sine is cos. So if f at x equals sine x, f prime at x equals cos x, or if it's in y equals notation, y equals sine x, then dy dx would be cos x. Then we repeated the activity and we looked at, well, what if I have cos x? So again, I've just started with a basic cos x. When you plotted all of your tangent slopes, you would have gotten something that looks like that. It's not quite sine. What it is an upside down or a flipped sine. So in this case, the derivative of cos is negative sine. So if f at x equals cos x, f prime at x equals negative sine x, and again, just using Leibniz notation, which is the y equals, if y equals cos x, then dy dx would be negative sine x. So really, in order to do any trig derivative, you just have to have those two facts memorized. The derivative of sine is cos, and the derivative of cos is negative sine. Because, yes, we have tangent, but the derivative of tangent is just based on sine and cos. So I'm going to look at some examples. The first one being, what if our function is just tan of x? Well, hopefully from grade 11 in advanced functions, you remember that you have a quotient identity, which means tan of x is the same as sine of x over cos of x. So in this step, I'm not doing the derivative yet. I'm just taking tan and rewriting it as sine over cos. Now I'm going to start the process of taking the derivative, and this is a quotient. I have sine over cos, so I'm going to apply our quotient rule from the first part of the derivative unit. So quotient rule says I take the derivative of the top is sine, so the derivative is cos, times the bottom, which is cos, subtract. So now I'm going to do subtract the derivative of, the top, which is just sine x, times the derivative of the bottom. Well, the bottom is cos x, and the derivative of cos x is negative sine x. And I've put it in brackets to ensure that this represents a multiplication, not subtract. So, derivative of the top times the bottom, subtract the top times the derivative of the bottom, all over the bottom squared. And remember, cos squared x is just another way of writing cos x squared. We don't want to use the brackets, but we don't want to drop them because then it looks like the x is squared in that case. So now I'm going to clean this up a little bit. Cos times cos is cos squared. Negative sine times negative sine is positive sine squared. Okay. Hopefully this looks familiar to you as well. This is one of our identities. This is the Pythagorean identity, and it is the basic one, that's sine squared plus cos squared always equals 1. So because I have cos squared plus sine squared there, that's 1 over cos squared. And again, going back to advanced functions, and then maybe a little bit in grade 11, we have these reciprocal trig identities. You can leave the derivative of tan as 1 over cos squared, or secant represents the function that is the reciprocal, or 1 over. So 1 over cos squared is the same as secant squared. So the derivative of tan is always secant squared. Looking at some more examples where they become a little bit more complex. So number 2, y equals the sine of x squared. So this shows why we move the 2 around when we're talking about sine squared, because this 2 is locked with the x. This is going to involve our chain rule, because our outside function is sine, and then our inside function is x squared. So to do the derivative, in this case it's going to be dy dx, because I have y equals notation. I do the derivative of the outside, so the derivative of sine is cos. Keep the inside the same. But then chain rule says you go and look inside and multiply by that derivative. So I'm going to multiply by 2x. Now here's where you have to be careful. This cos x squared is one thing. This 2x can't be combined with the x squared because the 2x is not part of the angle. So a lot of the times we'll bring the 2x to the front just to remove any temptation of combining it with the angle. Because when we do the derivative of x squared, we're actually taking it out of the trig function, so it's no longer considered part of the angle. Okay, now I'm going to work with cos, and I'm going to put the square now on the cos instead of the x. So remember, this is another way of writing cos squared. So this is going to involve power rule and chain rule. So f prime. The most outside thing is that exponent 2. So power rule says the exponent comes down in front, you keep everything the same, and then the exponent drops by 1. So we have a little 1 there, which we don't need because it's 1. So that's the 2. Now I have to look inside and do the inside derivative. Well, the derivative of cos is negative sine. So then that's that part. So I work from the outside in. My most outside is the square. 2, keep it the same, 1. Now I look inside. My next inside thing is the cos. The derivative of cos is negative sine. Now technically I should look at the angle as my last part. In this case the angle is x, so the derivative is just 1, so it doesn't impact anything. But if this angle was 2x or x squared, I would have to do the last step where I multiply by that derivative. And then I'm just going to clean this up a little bit, and it's going to give me negative 2 sine x cos x. Okay, y equals sine x plus tan x to the exponent 4. So dy dx. The first thing I'm going to deal with is the 4. Power rule says 4 comes down and the exponent drops to 3. You do not do the derivative of the inside at this point because chain rule says then we go back and multiply by the derivative of the inside. It's not the derivative of the outside of the inside. It's the derivative of the outside, keep the inside the same, then go back and multiply by the derivative of this inside. Well, the derivative of sine x is cos x, and I don't have to worry about multiplying by the derivative of x because it's just 1, plus the derivative of tan x, well, that was our first example. I'm going to write it as secant squared. And again, that's just coming from our first example where we found that the derivative of tan x is secant squared. It's expected that you have that one memorized, kind of like you do that the derivative of sine is cos and the derivative of cos is negative sine. And that's the derivative. It's not very pretty or simplified, but that's the answer. One more where we include the idea of the equation of a tangent. So, find the equation of the tangent to the curve y equals x times cos of 2x at x equal pi over 2. So whenever we're asked to find the equation of a tangent, we're using our modified slope formula. Modified meaning we only leave room to put in one point and we leave the other one with letters to get the y and the x in our equation. I shouldn't have put that y1 there. I'm going to replace that with a number. But I do know that my x-coordinate is pi by 2. I'm going to figure out what y is by subbing pi by 2 in for x. So I have pi by 2 times the cos of 2 times pi by 2, which is pi by 2 times the cos of pi, because 2 times pi divided by 2 just gives me pi. Well, that's the same as cos of 180, cos of pi. You can go into your calculator, or I know that it should be negative 1. So when you type cos 90 or cos pi, depending what mode you're in, you should get negative 1 because on our graph, at 180 or halfway, it has a value of negative 1. So this becomes pi by 2 times negative 1, or negative pi by 2. So now I have y subtract negative pi by 2, so I'm going to change that to plus pi by 2. And I apologize for that mess, but it's y plus pi by 2 over x minus pi by 2. Now in order to get the m represents the slope of our tangent. So I'm going to start by finding the derivative. So y equals x times cos of 2x. I'm going to be applying product rule in this case because I have the multiplication of two functions. So dy dx is going to be the derivative of the first, which is 1, times the second, plus the first times the derivative of the second. So the outside function is cos x. The derivative of cos is sine. I keep the 2x because I keep my angle the same. But now, because my inside function is 2x, I have to go back and multiply by the derivative of that, which is 2. So 1 is the derivative of x, keep cos 2x the same. Keep x the same. The derivative of cos is negative sine. Keep the angle the same. But then chain rule says look inside and multiply by the derivative of that angle. I'm going to clean this up a little bit. And I get cos 2x minus 2 times x sine of 2x. Now, I have my x value. My x value is pi by 2. So this is going to become the cos of 2 times pi by 2 minus 2 times pi by 2 times the sine of 2 times pi by 2. And again, a lot of you might realize that this is just going to be pi, and you can write that in the first step. But I just want you to see where I'm getting my answers. So cos of pi is negative 1. We already established that. You could type it into your calculator using the pi button in radian mode or 180 in degree mode. So that's going to be negative 1. Subtract pi times, now the sine of pi. Again, you can go into your calculator and ask it what's the sine of 180 or what's the sine of pi. Or you can go back to a sketch. And I know it's going to be 0 because at the halfway point or at 180, it will be 0. So then my slope is just negative 1. So I'm going to come back over here and I'm going to get negative 1, which is really negative 1 over 1. I'm going to cross multiply, so I get y plus pi by 2 equals negative x plus pi by 2. I just cross multiplied. I'm going to bring everything to one side. I'm actually going to bring it to the left-hand side in this case so that my x becomes positive. Pi by 2 subtract pi by 2 is gone. So in standard form, the equation of the tangent would be x plus y equals 0. Or in this case, they may give it in y equals mx plus b form, just that y is equal to negative x.